Okay, today the combinations that we're going to be looking at are another way to count things, and this time we want to look at large groups where order does not matter. So there's going to be some situations in which it's not like we're handing out prizes, right, for second and third, but rather grouping things together, like say you're getting together with a group of friends for a picture, and there's a lot of different ways you can arrange you and your three friends. So you have four people in the picture, but the reality is some of those ways are duplicating other ways, right? So we want to take out all the excess, and we want to make sure that, since order does not matter as long as we're talking about the same 4 items. So the formula is right here, and again, it gets kind of quite complicated to look at, but we'll find some shorthand notations and ways to show our work. But notice this is what we were doing yesterday. So we had our permutations. We had n things taken r at a time. And this are part of that formula. Okay? So basically what you're doing is taking the permutation and then dividing it by the number of ways they're going to be, taken, so that you can get out all those duplicates, and you'll see how that works out in different scenarios. So you have 4 tickets to the county fair, and you can take 3 of your friends. You can choose from Abby, Brian, Chloe, and David. So how many different choices of groups of friends do you have? Okay. Well, one way is to list all the possible arrangements of the 3 friends and then cross out any duplicate groupings to represent the same groups of friends. So this has been done for you. So you could do, the whole list of all the total ways, right, to arrange your friends. However, noting that ABC, ACB, BAC, BCA, CAB, CBA all contain the same 3 people. So in that case, you only really have 4 different choices of groups to make, okay, to take to the fair. So what if you have 3 tickets and can take 2 of your friends? Now how many different choices do you have? You would have 6 different choices. So for finding the number of combinations, if we have 8 things taken 3 at a time and order is not important, you could use the formula. And this is how it'll work out, right? So since the permutation of 8 things taken 3 at a time is 8 times 7 times 6, you'll take 8 times 7 times 6 and you'll divide it by 3 times 7 times 6. I think some of the multiplication signs there got a little messed up. So divide that out, and the answer would be 56. So yes, I think the 2 and the 3 on the bottom cancel out the 6 on top, so those lines are all a little bit messed up. Okay, that looks better. So now you can kind of see which numbers are being canceled out so that you can multiply the 8 times the 7 and get the 56. So let's try it. So again, you start with your permutation of 9 things taken 7 at a time, and then you divide out the 7 factorial. Again, I think this one's going to be messed up. Sorry about that. Bummer. And when you simplify, you'll get 36. Okay, for 8 things taken 8 at a time, the answer would be 1. So let's take a look at how what the work looks like. Remember, you're taking, well, let's try this one. You're taking the permutation and you're dividing it by r factorial, okay? So if you're taking 8 different ways, and dividing it by 8 factorial, see what happens? Everything cancels, and you get 1. Okay? Let's look at this one. So, to get the combination, you would take the permutation and divide by r factorial. So we have 8 things taken 7 at a time, dividing by the 7 factorial. So our answer would be 8, or 8 over 1. Again, the permutation divided by 2 factorial, so 7 times 6 divided by 2 times 1 should give us a combination of 21 different ways. And I'll be showing you your calculator notation too on how to solve these. So with your 6 things taken 1 at a time, so you'll have 6 basically divided by 1, or just simply 6, so I won't even work that one out for you. If you're shopping at a bookstore, you have enough money to buy 4 books. There are 7 books at the store that you want to read. How many combinations of books can be purchased? So, how do we set this up? The total number that we start with is 7 books, and you can choose 4 of them. So this would look like the permutation, 7 books taken 4 at a time, divided by the 4 factorial. So 7, 6, 5, 4, divided by 4, 3, 2, and 1. So the 4's cancel, the 3 and the 2 cancel the 6, so that leaves 35 different ways to be able to count this combination. And again, we can put that in our calculator and be able to work that out. And then finally, we want to be able to tell whether it's a permutation or combination. So we're putting together yesterday and today, and what you're thinking about is the order important? Because if the order is important, then you have to use the permutation calculation. If the order is not important, then you will use the combinations. So 8 swimmers in a 400-meter freestyle race. In how many ways can the swimmers finish first, second, third? Does it matter the order? Yes, it does, because those are very different places, and once you've picked the first place, you'll have a different person for second place and third place, and there are 8 different swimmers. So it is a permutation, and how you would write it would be 8 swimmers taken 3 at a time, and so you have 8 times 7 times 6, or 336 different ways to choose those. Mainly, you want to be able to tell that it's a permutation. I would love for you to be able to set up the permutation notation, 8 swimmers taken 3 at a time, and then you could solve that. For track, your track team has 6 runners available for the 4-person relay. How many different 4-person teams can be chosen? Again, you have to decide, is order important? If you're picked for the relay, other than your speed, does it matter if you were picked first or if you were picked last? It's the same. You'll be in the group. So we have to eliminate all those overlaps. So this is a combination situation where we have 6 runners taken 4 at a time. So we would have to solve it like this. So 6, 5, 4, 3, divided by 4, 3, 2, and 1. Cancel out what you can and multiply the rest. And again, if we put this into our calculator, you could get the same solution using the notation on the calculator. So a pizza shop offers 12 different toppings. How many different 3-topping pizzas are possible? Again, this is a situation where it is a combination, because once you've picked your pepperoni, your sausage, and your mushroom, it doesn't matter whether you picked them first, second, or third, right? Order is not important. They would be the same 3 ingredients. We would have to get rid of all the duplicates. So our combination then would be a 12C3, which would be a 12P3 divided by 3 factorial. So 12 times 11 times 10 divided by 3, 2, 1. So I'll take this 3 times 2 is 6 into the 12 and leave 2 and get 220 different ways. And it was a combination. There are 15 members of student council. How many ways can you elect a president and a vice president? So again, this does matter, because when you go to choose your president, you have 15 choices. Then when you go to choose your vice president, there's only 14 left, and the order does matter. So this is a permutation of 15 things taken 2 at a time, 15 times 14. There are 210 ways that you could have picked your president and vice president.